Hello everyone, HMT is here with you to help you compute the area trapped between these two curves, the sine curve and the cosine curve, as illustrated here. Don't mind the red ink just yet. This is the region trapped between the sine curve and the cosine curve. We need to compute how many square units that's comprised of. The first step in doing these questions is to find where the curves intersect. That will tell you your integration bounds for the step after that. To begin that, set the equations equal. Sine x equal to cos x. We need to solve for x. Now what we're going to do as a first step here is divide both sides by cos x. The reason we're doing that is this. Currently we have two different trig ratios at work in the equation. If I divide both sides by cos x, I reduce that load to 1. Just one trig ratio will be in the equation on the next step. So tan x is equal to 1. To solve for x, we take the inverse tan of both sides. And the x values which solve this condition are pi by 4 and 5 pi by 4. If that seemed a bit quick, just remember that if you're in the first quadrant, and the opposite side and the adjacent side are both 1, you have a 45-degree angle, which is pi by 4. So the tangent of that value is opposite over adjacent, which is 1. And if you swing into the third quadrant, in this case the opposite side is -1, the adjacent side is -1, and if you divide those, opposite over adjacent, again you get +1 at 225 degrees, which is 5 pi by 4. So those are the two angles we have. They are also our bounds of integration. So let's set up our integral. It works like this. Top curve minus bottom curve is how you set up your integral. So the area will be computed in this way. The integral from the lower bound of integration, pi by 4, to 5 pi by 4 of top curve minus bottom curve. Let's examine the structure of what we've just set up. Have a look at the red ink here in the original graph. This is an infinitely thin or arbitrarily thin rectangle. The height of the rectangle, the length of it, is y-coordinate from this curve minus y-coordinate from that curve. That's top curve minus bottom curve. And the width of this thin rectangle is dx. And if you compute the area of that thin rectangle, it's length times width, which is top curve minus bottom curve is the length of that rectangle, and that's the width. So this part of the expression is actually the area of one arbitrarily thin rectangle. And when you put an integration symbol on the front of it, you are summing up an infinite number of infinitely thin such rectangles which comprise your area. So we just proceed by taking the antiderivative of this expression first, and that's going to give you antiderivative of sine x is negative cos x minus, and the antiderivative of cos x is sine x. And this expression will be evaluated from pi by 4 to 5 pi by 4. Okay. Now what we'll do is sub in 5 pi by 4 and pi by 4 in the expression and subtract. So that's going to give us minus cos 5 pi by 4 minus the sine of 5 pi by 4 minus the expression evaluated at pi by 4. So it's minus cos of pi by 4 minus the sine of pi by 4. So now let's evaluate these trig ratios. Cos of 5 pi by 4 is negative, that's a double negative, negative root 2 over 2. So that negative sign is that negative sign, and the cosine of 5 pi by 4 is itself negative. So that's why there are two negative signs here. Minus, and again, the sine of 5 pi by 4 is negative, so we have another double negative. Minus. Now the cosine of pi by 4 is positive root 2 over 2 this time. Remember, that negative sign is that negative sign. This is a positive quantity. minus the sine of pi by 4 is also root 2 over 2. So we're suffering with an awful lot of negative signs now. Let's start to simplify. So that double negative gives you a positive root 2 over 2. That double negative gives you a positive root 2 over 2. A double negative right in front of the brackets here, that is going to give you a plus 2 root 2 over 2, and a negative gives you yet another root 2 over 2. So all told, we have 4 copies of root 2 over 2, which simplifies in one final step to 2 root 2 square units of area. If you enjoyed this video, please like, subscribe, and share. If you have suggestions on topics you'd like to see covered, please leave that in the comments section. Thank you.